Lecture video for January 22nd. We're going to be doing a step-by-step binder lesson today. This worksheet is available on the extra stuff calendar if you want to print it off. Otherwise, you are totally fine to write this onto a separate piece of paper and keep it together with step-by-step binder lesson number 1. You're going to keep these separate from your regular notes. These are the notes that you're allowed to bring to tests and quizzes, just your step-by-step binder notes. So keep them organized and it will benefit you. All right, how do we find the slope of a table? Step 1. Step 1, we need to draw arrows bumping down both sides of the table. All right, and if you're just writing this on separate paper, why don't you copy down table number 1? What I mean by bumping down both sides is you start at the first number and you draw arrows that just kind of bounce their way on down, hitting every single number. So bounce, 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 bounce. All right, and I just say that they are bumping their way down the table. Step 2. Next to each bump, write how much is being added / subtracted each time. All right, and normally this is pretty clear. You can do it in your head, but you can subtract the first number from the second to figure it out if you can't. So looking at table number 1 here, to go from 0 to 1, that's clearly a +1. To go from 1 to 2, that's another +1. And typically this will be consistent all the way down, +1, +1, +1, +1. All right. The reason we do all of them is because we're checking to make sure that this table is linear. Because if it's not linear, we'll see differences on one or both sides, and then we can't find the slope. All right, on this side, a little bit harder. What do we add to 2 to get to 5? We add 3. If I couldn't figure that out, I could do 5 minus 2, and then I would get 3. 8 minus 5, and again, it's +3. 11 minus 8, again, it's +3, +3. All right, step 3. Label the change on the left as delta x and on the right as delta y. So back to table 1, this over here, this has got to be delta x, the change in x, and this over here, this is the change in y. All right, step 4 is pick one pair of delta x and delta y and write, that's the wrong write, it as the fraction delta y over delta x. Pick one pair of delta x and delta y and write as the fraction delta y over delta x. So the vast majority of the time, these are the same number, so it doesn't matter which pair you pick. If we see some variations, you would actually probably want to compute every single delta y over delta x to make sure it's constant, to make sure this is linear. But I'm just going to do 3 over 1, so delta y over delta x equals 3 over 1. And then the very final step, this is often our last step, is to simplify. So step 5, simplify your fraction. All right, so 3 over 1 just becomes a 3. And that is our slope. We might label it as m, because m is the letter we often use for slope, like in y equals mx plus b. Okay, so table 2. Let's draw those arrows bumping down both sides. Let's figure out what the change is. On this side, we are adding 1 each time, so plus 1, plus 1, plus 1, plus 1. On this side, we're adding 4 each time, and if I wasn't sure, I could do 9 minus 5 is 4, 13 minus 9 is 4. I would say it's 4 every single time. This side is delta x, this side is delta y. I'm going to pick a pair of change in y over change in x, or rise over run, equals 4 over 1 equals 4. Let's try another one. So arrows bumping down, arrows bumping down. This side's going plus 4, plus 4, plus 4, plus 4. This side's going plus 2, plus 2, plus 2, plus 2. This is our delta x, this is our delta y. Delta y over delta x equals 2 over 4. To simplify this fraction, we can divide the top and the bottom by 2, and we get that 2 over 4 is the same as 1/2. All right, and fractions are very common with slopes. Because slope is rise over run, that just lends itself to lots of fractions because the formula itself has a fraction. All right, let's look at this one. It's got all 7s down one side. Well, that's not going to change our approach. We'll still draw our arrows, write how much it's changing by. This side over here, it stays constant, so this is just plus 0, plus 0, plus 0, plus 0. This is your delta x, this is your delta y. Delta y over delta x equals 0 over 1. 0 divided by anything is just 0. All right, something weird's happening with this one. These are all plus zeros, but now that's on the left as delta x. This side over here looks like it's adding up by 2's. But now we've got delta y over delta x equals 2 over 0. And this is different. Anything divided by 0 equals undefined. This doesn't have a slope. In fact, if we tried to plot it, it would be a vertical line, and vertical lines don't have a slope because they never run. They only ever rise and fall, but just on a single vertical line. All right, so we'll just kind of, let's add that into our notes that this must be a horizontal line if it has a 0 slope, and this one must be a vertical line, which has an undefined slope. All right, I'll embed a few more questions for you guys to do here. Let me zoom out so you can see the whole thing. If you want to pause it there, make sure you didn't miss anything, and have a good rest of your day.